Hello friends, my name is Javed Akhtar and today we are going to learn MapReduce of Hadoop. So as we in earlier lectures we have just understood the SDFS part. As we know that Hadoop system can be understood in two part, that is one is SDFS and another is MapReduce, where SDFS was for storing the huge data in a very specific manner and MapReduce is to process the huge data. Now SDFS part is already discussed and now we will go to understand the MapReduce part. Okay, let us understand it. MapReduce. MapReduce is a technique of processing huge data. In this technique, we will understand how we process, for example, suppose on a Facebook, Mark Zuckerberg has shared a photo, which is very unique pic. So worldwide, everyone will be liking, sharing, okay, different comments will be there. So now a query has been sent to that data that give me the output how many likes has came from India only. So there is a huge data on that peak and on that peak will be inside a huge data also. So we need to get out the output as per requirement of the query. So this is a big data and we need the such number of likes. So this can be achieved by using MapReduce. Okay, so let us understand what is MapReduce as definition first. Okay, definition of MapReduce. So the process of getting client query and depending on the query working on the correlated data and processing it and collecting the output and then storing the output is called MapReduce. So you have your data inside the data center. Client is querying. After getting query, using the nodes as we have discussed, the name node, data node, job tracker, task tracker, depending on those nodes, using that nodes, working on this stored data and getting the output, the whole process is known as your MapReduce part. So when query comes, after that mapper does something. Mapper is a function we will be discussing, then reducing that whole data and will be storing the whole resultant output in a file. This whole part is called your MapReduce part, that is getting the output depending on the query. Okay, now MapReduce part can be understood easily by splitting the MapReduce the whole word. So MapReduce can be splitted as map plus reduce. Here map is another process and reduce is another process. Reducer we will be discussing. So let us understand first map. Okay, let us understand the map part of MapReduce. Now map is nothing but involves a algorithm depending on which process has been done. Process will be done. So but one thing I want to make it clear here, that this map is not map as the memory mapping. We use the mapping to map a main memory to cache memory, like one page of main memory, how it will be mapped to the cache memory. One block of the cache memory, one page of the main memory will be mapped to the cache memory, like we understood direct mapping, associative mapping. So that mapping is different, that is the memory mapping. But this map is not the memory mapping. This map is nothing but the involves an algorithm which processes the data. Okay, so this should now as this map involves mapper algorithm, that's why it is called map process. Now in this map process, what is done is, we have understood that already our data has been stored in HDFS way in our data center. Suppose our data is stored in a cluster. I am taking a one cluster only here. Although in a data center there is huge number of clusters exist, I am taking an example of single cluster which involves a single job tracker, single name node, several task tracker and several data nodes. Now this is a single cluster. Similar lots of cluster are present there. So suppose a client has stored its own data in a data center in a single cluster which is present in this. Okay, in this data there is the client's data is existing. Now the client is here, he queries something and that query goes from Hadoop to the job tracker. Mind it, not goes to the name node. Okay, so it goes to the job tracker first. Through Hadoop system it goes to the job tracker first. Now job tracker understands that on what data the query needs to be run, but it do not know that at which place the data is stored. So job tracker does not know that at which address the data is stored. Now what job tracker does is contact to the name node. Name node, as we know, that already had every information about the data stored, that which place at what address data has been stored. So this name node will provide the address of the required data so that it can proceed further. Okay, after getting the data information, job tracker, what it does, it splits the data. It splits the whole work. Suppose a query has been generated that count the number of likes on a Facebook for a single pic shared by someone. So that counting, I'm just taking a small example, that counting is a process which needs to be done. So that process will be divided by this job tracker. That is, the query is to count the number of likes. It will come here, that name node will get that will provide the data where on which the working, on which the likes need to be count, and job tracker will divide the whole process in a, it's like there is a lots of work, and you divide those work in two different human beings so that the work can be easily completed. So same task is done by job tracker. It divides the process in several parts, and each part assigns to different task tracker. Task tracker is nothing but the slave of job tracker, and what it does, it goes to the data nodes, corresponding data nodes as per the task assigned by the job tracker. Okay, so each task tracker will get the corresponding job. Now it will go to the data node, but a single data, as we know in a SDFS system, a single data node has by default has 3 copy. So on which data node that task tracker will go to work upon, that depends on the where the data nodes are actually nearer to the task tracker assigned to do work. Now this task tracker has got, suppose assigned, is associated with this data node 1. Why it is associated with data node 1? Because the task assigned by this job tracker to this task tracker 1 is its required data is stored in data node 1. That's what TT1 is associated with data node 1. Similarly, suppose this T2 is associated with data node 3, T2 4, and TT3 to 3, and T2 4 and 5 to 6 in this way. Okay, job has been assigned. Now that task tracker got the job. What it does is, it initiates a process called map, which task is to do the job using this data, and that process is initiated as algorithm. So map is an algorithm which is initiated by this task tracker, and that will be called, and it will work upon this data node 1. So this task tracker initiated the map algorithm, so this whole process is not known as map process. So a mapper has been initiated to work upon this data. Now suppose different data like A, B, C, D, E, F, these are files stored in this file system. Suppose in this data node AB is stored, C, D, E, F and G. These all data are stored on which we need to work. Now when task taker job is to initiate the algorithm mapper algorithm. That mapper algorithm is initiated by task tracker, any task tracker. Now one task tracker initiates one mapper algorithm, but actually it is not the case. A task tracker may have several instances depending on the case that a task tracker assigned need to work on one slot of the data node or different slot of data node. Okay, so suppose on these two files a task tracker needs to done. So what it does, it initiates the two process. So two different process has been initiated, suppose A and B of client 1 and client 2, suppose like this. Then what it has been done, then task tracker 1 will be instance of the task tracker 1 will be created. So suppose instance of the task tracker is created by TTA1 and TTA2, TTA1 and TTA2. Now this task tracker instance has nothing but the process running on separate JVM, so that their work will be separated to each other, they will not interrupt to each other. So on separate JVM working means separate work will be done. So each task tracker run on separate JVM, Java Virtual Machine. Now this task tracker A1 is working on this data slot and this working on this data slot. So two tasks have been different. Now each task tracker instance will initiate a mapper algorithm. Okay, so here two mapper algorithm will be created, that is for this one mapper and for this one for B two. So two mapper will be initiated by this task tracker 1. So actually ultimate case here we need to understand that number of instance of a task tracker running will be equal to the number of mapper initiated. So one task tracker instance will initiate one mapper algorithm which will work on our data. Okay, so what should we write, that number of task tracker number of input splits. So these are nothing but the input splits. A data has been came, which was we have understood earlier that data was splitted as per the blocks. So each block is having, one block is having A, another block is having B, another block has been C, in this way. So each block is nothing but the input splits. Now these input splits, depending on that number of input splits, that number of mapper algorithm needs to be initiated. Okay, so there are 6 number of input splits of your data has been stored. Now how many number of mapper algorithm will be initiated by task trackers? 6. Okay, so but here only 2 3 4 5 6. Okay, suppose A B C 2 3 4 5 6. Okay, not G, suppose. So total 6 input splits are there, and that 5 is associated with this DN5. Okay, but how many tasks are running? 5. But actually what we have understood, that actually whenever there is 2 slots of data on which the task tracker needs to be run, then what it creates its own instance to run on separate JVM. So here also 2 instance of task tracker is created. So number of task tracker is 5. So how many number of mapper will be initiated? 5. But not the case, because there is task tracker 1 which will initiate 2 instance of itself, and each instance will initiate one mapper algorithm. Okay, So mapper algorithm here is 2, here is 1, here is 1, here is 1, here is 1. Total mapper algorithm is initiated by task trackers are task tracker A are 6. Okay, so we need to write it, very important point for us, that number of input splits is equal to number of mapper algorithm initiated to work upon. Okay, so this is very important. Okay, now we will understand by taking a very familiar example of a data. We will take a data set, we will store that data here, and we will query something, and then we will understand how the query will be processed and how it will give output. So let us understand by taking a very good example which is very familiar. Okay, let us understand the whole map process, and we will extend this map process in reduced part also. So first we will understand the map process by taking an example of a data stored by a client in Hadoop cluster. Okay, so let us suppose that our data is of size 400 MB. So data size is 400 MB. This 400 data is sent by client to store this Hadoop in this Hadoop cluster. Okay, so how it will be stored, we have already discussed in the SDFS part, which we have just before some lectures we were discussing. Now 400 MB will be stored in number of blocks, but how number of blocks? 400, because by default we are taking 64 MB size of each and every block. Okay, so 400 divided by 64 by 6 something. Okay, so 6 plus 1, total 7 blocks will be required. So number of blocks we need for storing 400 MB data is 7 blocks. So what are the number of input splits we will be required? 7 input splits. Okay, so suppose this is our whole data, it needs to be stored in this cluster. What Hadoop does is it splits the whole data in 7 input splits. Each input splits is of size 64, 64, 64, 64, 64, and the rest last, that is 7th block, will be of size 16 MB, and the rest will be remain empty. Okay, and can also be used for other data, but in the 7th block the data of this part is only of 16 MB. Okay, so number of input split is 7. Each of these 64 except this one is 16 MB. Let us assume that this each and every input split is a file. So name it a.txt, b.txt, c.txt, d.txt, e.txt, f.txt. Now our data has been stored. Now what we need to do it? We need to process it. How we will suppose that data A and B is stored in this node 1, data node 1, C is stored in data node 2, D is stored in data node D 3, and E is 4, and so on up to this data node 6, that is the G is stored in data node 6. Now all data is stored. Now our work is that whenever client will send query, we need to process it. So suppose this client is sending a query, and the query is nothing but count the total different words, number of times a different word has appeared in this data. So there, as you can say, there are lots of different words. Let me read you first. Raja is friend of Suraj, Suraj is friend of Chanchal, Javed is friend of Raja, Raja is friend of Suraj, Chanchal is friend of Mustaf, Mustaf is friend of Gargi, Gargi is friend of Mayank, Mayank is friend of Javed, Javed is friend of Gargi, Gargi is friend of Raja, Raja is friend of Kazi sir, Kazi sir is friend of Apurva sir, Apurva sir is teacher of Hadoop system, Hadoop subject. Okay, now we need, there is lots of words appear, that is Raja is a word, Suraj, Chanchal, Javed, Mustaf, Gargi, Apurva sir, Kaji sir, is, friend, of. These all are words, different words. We need to count it. So when you will count, you will find, as I have already counted it, you will find that Raja is appearing 5 times, Suraj is appearing 2 times, Chanchal is appearing 2 times, is appearing 13 times, Javed is appearing 3 times, friend is appearing 12 times, Mustaf is appearing 2 times, off is appearing 30 times, Gargi is appearing 4 times, Kaji sir is appearing 2 times, and Apurva sir is appearing 1 time. So these outputs we need. Okay, we need these outputs. So a client has generated a query. Where it will go? It will go to where? Name node? No, it will go to this job tracker to do its job. What job tracker will do? Job tracker will divide the task as per requirement, and it will assign to the task different the part of the task in different to the different task trackers. So suppose task tracker 1 is assigned to do the job for the file a.txt and b.txt. Now a.txt, b.txt is stored in data node 1. Now task tracker 2 is supposed assigned to work on the data C, so it is associated with data node 2. Task tracker 3 is assigned by job tracker to work upon the data d.txt, so it will be associated with data node 3, and so on. So all task tracker is associated with its own data. Now how data they have associated with? Are they have just asked to data node that data node, do you have the data which we are requiring to process on? No, because task tracker is slave of job tracker, but data node is slave of name node. So task tracker is a slave. Job tracker cannot find the data, cannot ask to the slave of the name node that what the data about you are storing. Okay, so it will contact with the name node. Name node will give reply that data you are requiring is stored in this data node 1, data node 2, data node 3, 4, 5, 6. Okay, so this is achieved by the job tracker. Depending on, after getting that job, it is assigning to the task tracker the jobs are, and then task tracker is able to find their own destiny where they are need to work upon. So they have got the associated. Now when task tracker got the job, what it does, it needs to read the data first, because without reading it cannot process it. So that reading is done by a process called record reader. What it does, data stored are called record, and record needs to be read. That's whole process is called record reader. So that record reader will be called by this task tracker. Before the mapping algorithm we have discussed earlier, mapping algorithm we need to call the record reader, which will read the data stored. So record reader, number of record reader will be equal to the number of input speeds. So there is a 2 input space stored in data node 1, so there is 2 record reader will be running here. Due to the one task tracker is initiated, instance of one task tracker that is task tracker 1 has 2 instance created. Each instance will be calling a separate record reader for reading. That is, one will read a.txt, another will read b.txt, and after reading it they will understand and it will generate output in terms of key value pair. Okay, key value pair. Why key value pair they are getting? Because mapper algorithm takes input in terms of key comma value pair only. They do not understand the whole raw data which you are feeding to the MapReduce. So they will not understand it. They only understand the key comma value pair in this form. If you feed the data to the MapReducer, then only it can process. So this is done by the record reader. What it does, it takes the raw data which is stored here. It takes the raw data. So task tracker, what it does, it initiates a record reader. Record reader does what, reads this data, and it converts it into the key comma value pair. Key comma value pair will be obtained by the record reader, and that record reader output, that is key comma value, will be fed to the MapReduce part. So now we will erase it and we will just concentrate on up to the initiation of record reader and Mapreduce and mapper algorithm, we have got the idea how they have been initiated. They are been initiated by task tracker. How task tracker assigned? By job tracker. Everything we have understood. Now we will go only by erasing this all. We will go only for understanding after this. That is after assignment of the job, after initiation of the mapper algorithm record reader, what the process needs to be executed, what the process what the things are to be done. We will understand it. Okay, up to what we have understood? We have understood up to the part where task tracker initiated the record reader and mapper algorithm. Okay, so until and unless record reader do not gives the output to feed in the mapper algorithm, it will not start its working. Okay, so mapper algorithm, the process mapper and the record reader is initiated by each instance of a task tracker. Now this all data is stored in data nodes, and we are taking only the 6 data nodes here. Why? Because only these 6 data nodes are required to are in these 6 data nodes our all data has been stored. So we are taking only the 6 data nodes of the single cluster. We are not showing the job tracker, task tracker, which we have already discussed here. Now what we are doing, that after assignment of the task to the task tracker by job tracker, we are understanding that task tracker is initiating record reader and mapper algorithm. So here task tracker 1 is assigned to do work upon the two files a.txt, b.txt. So task tracker will go to the data node 1. Why? Because data node 1 contains the A and B. So task tracker 1 is associated with data node 1. Fine. Now there are two separate files. So what it will do, it will, for parallel processing, it creates two instances of itself. So task tracker 1 will create instance of itself, that is task tracker A1 and task tracker B1. Okay, task tracker A1, task tracker B1 will initiate record reader to read the data. Okay, so it initiates the record reader A1 by task tracker A1, and task tracker B1 initiates record reader B1 to read the data. Now record reader A1 will go to the txt file and it will read. Record reader B1 will go to the b.txt file and it will start reading. Okay, how record reader will read the data? It will read the data. Suppose our record reader A1 is reading the a.txt file, which is this one, and that it will read one line at a time. So one line of this is Raja is friend of Suraj. This will be read at a time by this record reader A1. Okay, now next it will, after reading this, it will give some output in key comma value pair. Okay, again after reading first line, it has given key comma value which is reached to the Mapreduce to do its job. Now record reader, it will not start process. It will start process until unless the whole has record reader has read the whole input split. Now record reader A1 will again go to the second line. It will read the second line. It will give another key comma value pair and it will feed to the mapper A1. Fine. In this way, every record reader is doing its own job. So record reader 6, it will do what? It will go here. It will read one line. It will give key comma value pair output and it will go to the mapper algorithm 6. Now key comma value pair generated by this record readers depends how the key will be generated. So it is not the random case, there is dependency. Key value will be what? Depends on the type of file. Now as we have understood what type of key will be generated and in what terms of key comma value pair will be generated, it depends on the type of file specified the client during the sending the data. Okay, so suppose those type of files which the type of files a client can specify are in four. One is text input format, another is key value text input format, sequence file input format, sequence text input format. These are the four formats in which a client can specify its data type. Okay, now if a client do not specifies the type of its data format, then by default text input format has been understood by had been applied by the Hadoop system. Okay, now if the type of the file is text input format, how it will generate the key comma value pair? It will generate in such a way that it will count from this. Suppose this line is read by this record reader. How it will read? Suppose counting starts from 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. In this way it will be count. So counting has been started from 1 here for this line 1. So what will the key value will be? 1. So for this line key value will be 1 comma and value will be this whole line. The whole line will be the value. Okay, for the, so suppose the count, let us count it first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. End of the slash will also be, so 24. So 24, here we will count start 25. So 25. So for this line the key value will be 25 and this will be your value. In this way, if your file specified is text input format, key comma value will be generated. So here it will be generated 1 comma value. Here it will be for the second line it will be 25 comma value in this way. But suppose key value text input format is your specified file by client, then how the key comma value will be generated? It again it is like in a different fashion. It is like it will read, start reading the line. Record reader will start reading the line. It will start to read from here. Suppose Raja has been written, then there is a space. That first space, that is tab, has been understood by this recorder. What it will do? It will do that before this first tab, first space, the Raja thing will be taken as key value, and the rest of the part of the line will be taken as the value. So Raja is your key, is friend of Suraj is your value. So Raja comma is friend of Suraj is the key comma value pair. But for that file of that type of data, nobody is going to generate the specify the file type, file format, key value text input format. Why? Because this is not looking as a key, but can be. But suppose you have the data like 13 Raja went, something like this. So first tab has been obtained, again 14 Suraj something, again 15 Chansal something has been taken. So this after first space what you are getting is 13 is your key value, and this whole is your value is your value of the key comma value pair. Again for this after before first tab, this 14 is taken as a key, rest is taken as the value. 15 is taken as key, rest is taken as the value. In this way your key comma value will be generated for the key value text input format. Rest of the sequence file input format, sequence text input format will also be generating key comma value pair in different fashion. We will not bother about that. We will just first understand this text input format. Suppose our data has been generated and that key comma value is like 0 comma the whole value, and again second is 24 5 comma the whole value of the second line. So you got this whole value, it will be fed to the mapper algorithm map process A1, and this key comma value pair, that is this file, suppose this is ending somewhere and this has some key comma value, this has some key comma value pair. So again some key comma value pair to key comma value pair be generated and it will feed it to the mapper B1. After getting the map this key comma value pair, it will generate some output. What the output will be generated by this mapper? Let us see this first. Okay, after reading the data, mapper algorithm, after processing the data, it will give some output. In what format it will give output? For our case, we are counting the words, number of words. So for this case, it will count depending on the query written we have. depending on that query, mapper will run some process. Because we have written the query of counting the word, that's why mapper algorithm will run for the counting of the word, and that's why it will generate in this fashion that Raja word has counted one time for the first line. So for the single input split or record reader, how many times it will run? Because record reader is reading one line at a time. So for one input split, as many number of lines it will contain, that many number of times record reader will run. Similarly, mapper will run as many of times as many number of lines will be inside one input split. So in first input split there are two lines. So how many times record reader will run? Two times. How many times mapper will run? Mapper for the corresponding mapper will run two times. So after running first time key comma value has been generated, that will be feeded. After running second time key comma value will be generated, that will feed it to the mapper. First key comma value will be obtained by mapper algorithm, and what it will do? It will generate this output: Raja comma 1, Is comma 1, Friend comma 1, Off comma 1, Suraj comma 1. 1 is nothing but the number of counts has been achieved in this line for the corresponding words. Now it will again get the output of the second key comma value for the second line. That key comma value will be obtained by mapper algorithm 1. It will again generate the output Suraj comma 1, Is comma 1, Friend comma 1, Off comma 1, Chanchal comma 1. So these outputs has been generated by the mapper. In this fashion, each and every mapper will run and give some output. Okay, so now we will understand from here this output we have obtained. Now what will we do with this data, so that our purpose of counting words in the whole data will be achieved. So let us understand. As we have understood that a single query of counting the whole separate different words needs to be processed out and taken as output. So that's a single word now. So this counting word has been taken as single process. This has been assigned to different task trackers. Each task tracker is doing its own job for a particular data. Second task tracker is doing again a particular working on a particular data. Third task tracker data. After getting this all output, what we get? We get partially output. So work has been divided. Each task tracker will give some output. That output will be what? It will be partial, not as a whole, because partial work has been assigned. So partial output will be generated. Those partial output will be, we need to combine it. So what we are saying here, parallel processing is achieved. This is the why the whole Hadoop works very fast, as even the whole data is very big in terabyte, petabytes. You have the data, but as this parallel processing, we have just shown the single cluster. So there are lots of cluster, lots of machine are running, lots of data again there is. So every time for a single data on which the process needs to be, query needs to be running, parallel processing has been achieved, so that partial work can be achieved for a single system, and it will give some output, and then all partially output will be combined and will taken as output. So it is like instead of working one man on a single word, you are working 20 people or lots of people on a single word. So the work will be achieved in very less time. So parallel processing has been achieved. Okay, so now mapper has already generated the output. Up to this, of Mapreduce part, map part is done. That is, mapper has given the output. So map part has been complete. We have understood the map part. Now comes the reduce part. This output has been achieved by mapper algorithm. Now we need to do some process on it. This data will be fed to another algorithm which is known as reducer. What it does, it takes the output of the mapper as input and does two things. It shuffles and sorts the data and gives the output. Okay, so when a reducer comes into play, okay, so in this fashion, this mapper has given some output. This mapper will also give output. this mapper will also give output, this mapper will also give output, this mapper will also give output. This all output will be fed to a single reducer which exists in a single cluster. For a single cluster, only one reducer exists on any data nodes it may be. So there are lots of data nodes in a single cluster. On any data nodes of the single cluster, the reducer algorithm may be existing, okay, but on single only. So suppose this is the reducer, which is nothing but an algorithm exists in a data node, okay. Now the output generated from the map algorithm part will feed it to the reducer, which is nothing but an algorithm. It will get the input. Now reducer is of two types. One is default reducer, which just only counts the which has the ability of just only counting, ability of only sorting, not the shuffling. And what is shuffling? Shuffling is the just combining all value into a collection associated with single key, okay. So for our this data, there is Suraj is 2 times, is 2 times, of is, so these all are repeated terms now. So it will be combined like is will be combined like is comma 2. So it has been shuffled. Shuffled means taking one single key and taking and counting that how many this single value has been appeared. So is appeared 2 times, and number of times it will be 1 plus 1 2. So is will be output of the shuffle for the is key, for the key is will be is comma 2. So I am taking is as a key. Suppose it is not that key, mind it is not that key. So is I am taking as a key, and that is one single word, okay, not the repeated word, which is different word of the data we are taking as a key. Suppose that different data is, now how many times it has been appeared is counted and written as this, and is comma 2 is your output of the shuffling. So shuffling is nothing but the collecting the all data in a collection associated with single data, single different word, single, in this case single different word, so you can do single key. So we got this. So that is shuffling. So that is not present in default reducer. It do not does this thing. So what we do, we will use the user reducer, okay, not default reducer. In user reducer, depending on the logic written by the client user, it will give the output. Suppose this all data has been came, so user reducer, it will come to the user reducer, and reducer will contain some algorithm which will come some code. Code will be such like that it will shuffle the data. So shuffling means again for the corresponding key, corresponding number of times appearance will be counted and will be written, and for whole it will be combined in a single way. So it has all data has been combined. So what will be the output here? For this case, Raja has appeared one time here, to Raja comma 1. Similarly for this case here it will be there. So all data will be combined. For Raja, here is only one, Raja comma 1. From here Raja comma 2 may be appearing. From here Raja comma 3 may be appearing. From here Suraj comma 3 may be appearing. From here Suraj comma 2 may be appearing. This all data will be combined. So Suraj is coming from here, Raja is coming from here, again Suraj is coming from here, Raja is coming from here also. So all data again shuffling will be done. So all, not only shuffling of this only one output, shuffling means all combining the all data, then it will be shuffled, and for one single word number of counts will be generated, and that will be stored here in the data node in which the reducer algorithm is running. So suppose this is a cluster and lots of suppose this is a cluster and lots of data nodes are present in this cluster, and okay, we got that this in a single cluster we have lots of data nodes. Suppose in this data node our reducer is running, okay, so this will take the shuffling output, okay, and it will sort the output, okay, and it will, after sorting, it will store in this data node the output, okay. So output will be stored in that data node in which reducer algorithm is running. So output has been, suppose output has been stored. after storing the output, what it has been done, another thing comes. What it is record writer. What the work of record writer? It takes this output stored in this data node and write it to the client's directory, client's file. So writing the output of the file from this data node to the output file. Okay, we got the idea that we have got the output and it will be stored in the output file. Name is like part 1 2 3 4 5 0 are there in this like file of a client. That output file will be generated. So for our case, what will be the output? Let us write it. So for our case, output file will, okay, so our ultimate output will be these are, that is Raja 5 times, Suraj 2 times, and then each one is having the word which we are counting, and the second one is the number of times it has been appeared in the data in which upon which the client has requested to query and the count the words. So we got the data and these are the data we obtained. This will be written in the output file, the output file of the client, like part this type of file will be there. In that file of the client, this whole output will be written by record writer, as we have just earlier discussed. Now it has been running. The whole program was on 400 MB of data, which is very less data, but let us understand it as that this 400 MB data was not 400 MB, it was 400 petabytes of data or 400 terabytes of data upon which the query were running. So suppose this whole 400 terabytes of the data upon the query would be running, so how much it will take time to count the word. That's why Hadoop makes it easier by providing parallel processing, and in this way we have just discussed for the one cluster, but it is for that much amount of data there will not be only one cluster, so there will be lots of cluster upon which data will be there, and hence there will be lots of nodes like task tracker, job tracker, name node will be running on that, and it will be stored and it will be running on lots of machines. So huge amount of data will be processing in huge number of machines, so the total time will be very less for the finding the output. So fine. Now after this we will just configure standalone mode of the Hadoop. Why standalone Hadoop, not the whole? Because for us only one system is there and we can afford the lots of nodes to available for that. So we will configure the Hadoop in standalone mode, and we will have some data upon which we will write some query and we will generate some output, and we will see those all things practically. Okay, so in our next session we will be doing this all stuffs. Now okay, the last thing which is I think very important, that please do like, share and comment so that in future we can create more videos like this for our understanding purpose. So let's help to get help. Okay, thank you.